This is my Project 2.1 breadboard prototype of the digital to analog converter. The DAC has several parts, some of which are the switch bank, seen here and here, the 7 5.1 kilo ohm resistors, seen here, 9 10.2 kilo ohm resistors, seen here, an LM741 operational amplifier, seen here and here, a resistor network, seen here and here, and a power supply. In the DAC, the 8 digital inputs will each represent a fraction of the total supply voltage. Each bit will be worth half as much as the bit before it, with the biggest being on the right and the smallest being on the left. This results in the rightmost switch, or bit, being half of the total supply voltage and the most significant bit. The bit after that is 1/4 of the supply voltage, and then 1/8, and then so on until the very, very end, where the final bit is worth 1/256 of the supply voltage. All these switches together will result in virtually all total voltage at 255 out of 256 of the supply voltage. The next important part of the circuit is the voltage follower. This is the reason for the LM741 to be in the circuit. The voltage follower is a circuit in itself where you connect the output of the LM741 to the inverting side to an inverting input. This allows for the op-amp to self-regulate its own ampage to allow for a consistent output that isn't dampened by all the resistors. This allows for more consistent output that's easily read. Another important part of the PCB is the 90-degree bent female headers seen on the far right and the bottom of the board. The bottom of the board female headers allow for outside input of the 8 digital inputs. This means you can connect another circuit to this circuit and have them put together. The one on the right is an alternate way to power the circuit before you actually solder the power jack in, and it gives you a pin that the output will come out or the analog voltage will come out. After the circuit has been completed, the next step is to create a PCB. A PCB is a printed circuit board, and it is created on Easy EDA, and it's a much more efficient way to create a circuit. It has things called traces. These are like wires, except they're much smaller and can be on the top and the bottom half of the board. This allows for much more compact and consistent builds. The PCBs are made on a site called Easy EDA. Easy EDA allows you to create a schematic in a circuit, then transfer that circuit over into a PCB, and then finally make it into a 3D image of what the PCB will look like. Then you can order it, and within 3 to 4 days, if you're lucky, you can get your PCB. The final step in the process is making a 3D printed case on Fusion 360. The benefits of making a case, it allows for a more professional and a more usable PCB. It also gives the allowance for having batteries underneath the board, and you can put a logo and your name on it to personalize it to yourself. The case adds the last final touch of usability and creativity to make any circuit whole.